Well, hi there, boys and girls. Today we're going to take a look at how to find exact values of our trig functions. And this first sheet here that you have in your notes is simply some things for you to remember. And this first one is in these quadrants that will help you with whether or not sine, cosine, tangent, whether or not they're positive or negative in those quadrants. So looking at this box over here, this is quadrant 1, and all of our trig functions are positive. So the A stands for all. This is quadrant 1. Every trig function is positive in quadrant 1. In quadrant 2, the only trig function that is positive is sine. Tangent and cosine are both negative in quadrant 2. And then in quadrant 3, tangent is the only one that's positive. Sine and cosine are both negative in quadrant 3. And then C stands for cosine in quadrant 4. It's the only one of the three that's positive there. So it's all students take calculus. That's the mnemonic for that. If you do your reference angles correctly and you label your sides, you won't have to worry about that. Now the last thing is, what about for the values that do not lie in the quadrants, that lie actually on the axes? 0, 90 degrees, 180, and 270. This is a chart that shows you their values, and I want to show you where this comes from so you can draw this picture and never get this wrong on a test or a quiz. So let's draw a unit circle. There, that's good. Alright, so this is all you need to know. Let's switch to blue so it shows up on the black here. We're going to put 4 dots. There's a dot at 0 degrees. Here's a dot at 90 degrees. There's a dot at 180 degrees. And here's a dot at 270 degrees. If for some reason your angle lies on any of these 4 places, I want you to draw this picture and I want you to write these ordered pairs. Let's say this unit circle has a radius of 1. So this dot right here, we went out 1 and up and down 0. So it has a name. It's got an ordered pair, and that is 1, 0. At 90 degrees, this dot is 0, 1. And the dot at 180 degrees is negative 1, 0. And the dot at 270 degrees is 0, negative 1. Alright, so I want you to see that all of these dots go in the order x, y. We're going to call these dots cosine, theta, sine, theta. And you're going to need to know also that tangent of theta is the sine of the angle divided by the cosine of the angle. So let me show you how we got some of these answers up here. What about at 0? What's the sine of 0? Go to 0 degrees and look at your ordered pair. The ordered pair is 1, 0. The first number is the cosine. The x value is the cosine. The y value is your sine. So if you want the sine of 0, go to 0 degrees, look at your ordered pair. The sine is the second number. It's 0. What about the cosine of 0 degrees? Well, the cosine is the first number of this ordered pair, and it's 1. Now, tangent is 0 because tangent would be sine divided by cosine. So the tangent of 0 would be sine divided by cosine. 0 divided by 1 is just 0. Let's take a look at the 90 degree angle, and I think you'll figure out the rest of them. At 90 degrees, what's the sine of 90 degrees? So you rotate to 90 degrees, you're on this y-axis, the positive y-axis. This ordered pair is 0, 1. The sine is the second number, so it's 1. The cosine is the first number, so it's 0. And the tangent of 90 would be the sine of 90 divided by the cosine of 90, which would be 1 divided by 0, and anything not 0 divided by 0 is always undefined. We've just got a big U there. That just means we're dealing with a vertical asymptote. And when we do our trig graphs, you're going to see that tangent has vertical asymptotes at 90 degrees and also at 270 degrees. So hopefully you can reason through these next two without me talking you through it. If not, just let me know in class and I'll help you. Alright, so let's do, I think we've got 3 examples for exact values. So we are going to use reference angles to figure this out. Everything we've learned before is going to wrap together to do this. And this might be the most important thing for calculus that you learn in pre-cal, to be able to find the exact value of trig functions at different angles. So what we're going to do is we're going to find 240 degrees. 240 degrees would be out here in quadrant 3, past 180 but before 270. So let me just at least draw it first. So it's out here somewhere. Now where does our reference angle go? Reference angle goes between the terminal side and the x-axis. So that reference angle is right here, and I have to figure that out. I rotated around 240 degrees, so my reference angle, or theta ref, would be, if it's in quadrant 3, we do angle minus 180, and that will give us our reference angle. So we know that we are dealing with a 60-degree angle right here. This is 60 degrees. So I'm going to erase this and show you how we're going to draw our triangle. We are going to take and draw an altitude directly to the x-axis, and we're going to create a right triangle. This is going to be a 90-degree angle. We just figured out that this reference angle is 60 degrees. That makes this other acute angle a 30-degree angle. So what we're going to do is draw on our knowledge of 30, 60, 90s. I'm going to put a 1 across from the 30-degree angle, but I'm going to make it negative because we are going left on the x-axis. I'm going to put a square root of 3 across from the 60-degree angle, but it is also going to be negative because I went down. And the hypotenuse is a 2. This is our basic way of labeling a 30, 60, 90. By the way, never, ever, ever make your hypotenuse negative. Never make your hypotenuse negative. The Pythagorean theorem would guarantee that it's positive. Alright, so what I've done so far is I went through my rotation of 240 degrees. I figured out my reference angle. It was a 30, 60, 90, so I knew to label my sides in the appropriate way. Now I'm going to find the sine of 240 degrees by knowing that sine of the angle is opposite over hypotenuse. Sine is opposite over hypotenuse. So let's focus our eyes on a reference angle right here, 60 degrees. The opposite side is negative square root of 3, and the hypotenuse is a 2. And that is the sine of 240 degrees. Whenever you evaluate a trig function, your answer is always, always, always a fraction. Let's take a look at the tangent of 3 pi over 4. Draw my axes again. 3 pi over 4, oops, I wanted that one. 3 pi over 4 is in quadrant 2. If you do your degrees, it's 135 degrees. And I'm going to drop an altitude always to the x-axis, making a right angle. So this is 90 degrees. Now what is my reference angle? My reference angle is always the angle between the terminal side and the x-axis. I've rotated through 3 pi over 4, so what is left here for my reference angle is pi over 4. My theta ref is pi over 4. Now why is that? Well, in quadrant 2 you want to do pi, since we're in radians, we're going to keep in radians, minus our angle. And I'm going to convert this into common denominators. So 1 pi is 4 pi over 4, and if you subtract them, that's how you get that this reference angle is pi over 4. So I'm going to go ahead and call that 45 degrees, and then the other acute angle is 45 degrees. Consult your degrees to radians. Remember that pi over 4 is 45. And we're going to label our sides. I'm going to label this side across from the 45 a 1. I'm going to label across from this other side a 1, but I'm going to put a negative on it because we went left. And then on the hypotenuse, I'm going to put a square root of 2. This is our basic way of labeling a 45, 45, 90 triangle. Then I'm going to go to SohCahToa. What is tangent? Tangent, toa. Tangent is opposite over adjacent. So you're going to look at this reference angle, you're going to go to the opposite side and divide by the adjacent side, and you're going to get 1 divided by negative 1. Which we could just call negative 1 if we wanted to. Alright, last example. Secant of 5 pi over 6. So again, I'm going to try and find 5 pi over 6. I'm going to find my reference angle, draw my triangle, and that's what I'm doing. So 5 pi over 6 works out to be 150 degrees if you convert, or you could think about it as this is 0 pi over 6, convert to common denominators. This would be 3 pi over 6. Pi over 2 is 3 pi over 6, or half pi. 1 whole pi would be 6 pi over 6. So 5 pi over 6 lies over here in quadrant 2. Alright, so let's finish by drawing our altitude always to the x-axis, making your right angle. Since we could convert that 150 degrees. We know that this reference angle is 30 degrees. How do we know that? Well, we've done a quadrant 2 before, but I'll do in degrees for this one. We do 180 minus our angle in quadrant 2, and that gives me my reference angle. So this is a 30-degree reference angle. That makes this a 60-degree not reference angle, just angle. And now I'm going to label my sides. I'll put a 1 across from the 30 degrees. I'll put a negative square root of 3 across from the 60 because we're in quadrant 2 and we went left. Then on the hypotenuse, I'm going to put a 2. Now the secant of 5 pi over 6 is the reciprocal of cosine. So it's 1 divided by the cosine. Or instead of adjacent over hypotenuse, I'm going to do hypotenuse over adjacent. And with the negative, I'm just going to put it out in front. And there is your answer. All right, so you guys are going to work on exact values tomorrow, and I will see you then.